Good evening, students. Today we are going to start our new chapter of chemistry called carbon and its compound. The content of the chapter is like this. We have to learn about carbon. What is this carbon? What is its atomic number? What is its mass number? What is the electronic configuration of carbon? What are the other important properties of carbon? So considering that the valency of the carbon from the electronic configuration we can observe is the 4. Therefore, it is called as the tetravalent. They react or they combine with the other atom or other element by sharing of electron. So such bond formation is called covalent bond. So we have to learn about what is tetravalent, what is covalent or covalency. This carbon exists in different forms. Chemically, they are carbon, but physically they appear different, like diamond and graphite. Both of them are carbon, but their appearances are different. Their properties are different. That is called allotropes or allotropism. So we have to learn about allotropism. Another, they combine with hydrogen to form the compound called hydrocarbon. And the compound form have different behavior or different characteristic than the compound of all the other remaining element. So this group of compound formed by the carbon is called organic compound. So we have to learn about the organic compound and their properties. Their molecules also showing different behavior, like for the same molecular formula we may get different structural formula. That property is called as isomerism. So we will learn about the isomerism. Carbon can link with the other carbon atom to form a longer chain. This property is called catenation. So we have to learn about the catenation. So these are the important properties. Some other properties of carbon we will also learn. Then whatever the compound form, how they are named. So nomenclature of compound we will learn. Then we will learn the functional group. The two important functional group and their reaction we have to learn. First one is alcohol and other one is the carboxylic acid. And the last topic of this chapter is soap and detergent. A student, let us start with the carbon. What is this carbon? So carbon is one of the element which is denoted by C, and its atomic number is 6 and mass number is 12, though there is another kind of carbon with mass number 14 is also found. That is called as the isotopes. But most of the carbon exist in nature is in the form of atomic number 6 and mass number 12. So the carbon 6 and 12, this is the denotation. Or if we consider the 14, the atomic number always remains the same. So 6 and 14. So these two are isotope of each other. We have learned isotope are those atoms or atoms of same element having same atomic number but different mass number. This different mass number is due to the difference in their number of neutrons present in their nucleus. So it is this way. How they are existing? Their existence. So this carbon can exist in many forms. They may exist in the form of element or atoms as well as in the form of the compound. So in both the form this carbon is existing. If we consider the existence, so it can be in the atomic form, where we are observing this atomic form, like graphite, like diamond, like Buckminster fluorine, that we will learn later. So these are the atomic form of the carbon. They may exist in the compound form. In compound form, again, it may exist in free form as well as in the combined form, or it may exist in the gaseous, solid as well as in the liquid form. How they are? If we consider the air, so the carbon dioxide, carbon monoxide, these are the gases which are present in air. So in air it is found. If we consider the coal, so coal is what? Coal is also the carbon, or most of the content of coal is carbon, because while burning the coal we are getting the heat. Coal is used as a fuel. Coal. Another is petrol and petroleum. So from this petroleum we can get different component like diesel, petrol, CNG, etc. The other in compound form like alcohol or the artificial one, it is. So this carbon can exist in the various form. So why such wide existence of carbon, not the other element? Those things we will understand. For that we have to understand the properties of carbon. So what are the important properties? We have to start with that. Properties of carbon. The important properties that we have to learn are, let me list down those important properties what we will discuss here. Very first we will start with the valency. The valency of carbon is found to be 4. How it is 4? Everything I will explain. And they combine through the covalent bond. So it is also called as tetracovalent. So it is your tetravalent. Another one is the type of bond between the atoms is your covalent. So it is also called as covalency. Covalency. Combining this together in many of the book, it is also written as tetracovalent. Tetracovalency. Okay. So whether you learn these two separately or understand it in the same topic, mean the same thing. The next one is this carbon atom can exist in different form. One is in the form of their isotope, but not the isotope. So isotope is one of the way of existence where the atomic mass differ, but the same carbon, even the carbon 12 itself, can exist in different physical form. Means their physical appearances will differ. Like one is graphite, another one is diamond. So this thing. So that property is called as allotrope or allotropism. So allotropes or allotropism. So what are different allotropes that we will learn? We have to learn about the 3 allotrope. Very first one is graphite. The second one is diamond. The third one is Buckminster fluorine or simply fluorine. Fluorine. Even your coke, charcoal, all these are also the allotropes, but they are not most common. Okay? I mean, considering the allotrope, if it is asked whether charcoal is the allotrope or not, yes, charcoal is also the allotrope. Okay? So also you may write like this: coke, charcoal, it is. Even the chalk that we are sometimes observing containing the carbon, so chalk is also there, but these two are the common one. The next property is, all we will learn about everything, graphite, diamond, fluorine in more detail. The another important property, carbon can combine with the other carbon to form a long chain. That is the most important property. So that property is called as catenation. Catenation. So this is nothing but this is carbon-carbon linking or self-linking property. Because of this catenation, it is able to form large variety of compounds. So considering this catenation and tetracovalency, it is able to form a single or a different kind of or different group of compound called organic compound. So we will learn about the organic compound formation. So write that fifth one. What are the organic compounds? So this organic compound must have the carbon. Another important ingredient or constituent is the hydrogen. So in most of or in 99% of the cases, there must be hydrogen in addition to the other atom, like oxygen may be there, sometimes nitrogen may be there, sometimes phosphorus may be there, sometimes sulfur may be there. Okay, so all those things. Therefore, this organic compound is sometimes also called as hydrocarbon. So compound formation, organic compound formation. So hydrogen and carbon must be there in their compound. It is the ingredient. So hydrogen and carbon containing compound is called as hydrocarbon. Now, in addition to hydrogen and carbon, if there is something oxygen or say nitrogen or any other one, say sulfur, etc., means in addition to hydrogen and carbon, one or more other atom is present in their compound. It is called as derivative of hydrocarbon. So it is called as derivatives of hydrocarbon. So these two things we have to learn. So while this other atom or group of atom which is combining with the carbon, it decides the entire characteristic. So it gives the concept of functional group. So right, next one is the functional group formation. Why we have written? Yes, why we have written? So functional group, here we have to learn about this carbon containing oxygen and hydrogen, OH as one of the constituent. It is called your alcohol. Means this OH will present in that molecule. How it is present? Everything I will explain in more detail. If it contain CO or CHO, let me write directly. A structure I will explain later. It is called aldehyde. If it contain carbon with oxygen only, at that time 2 valency of carbon remains unsatisfied. It is called keton. Another, if this carbon, oxygen and OH is also there, only 1 valency of carbon is left unsatisfied, it is called carboxylic acid. If only oxygen is there, this is called as the ether. If there is the compound like COO only is there, that is called as the ester. Those things you will learn later. So ether, ester, if there is C and N is there, it is called as cyanide. But we have to focus about the first 3 or 4. Even in place of OH, there can be halogen atom, say chlorine only. It is denoted by X. So only chlorine atom is there in place of hydrogen. Fluorine or bromine, etc. Or maybe iodine also. It is called as the halogen or halo group basically. We will discuss in more detail. So what is this halo group? So what are the functional group? Those things we will learn. After this, we will observe another characteristic of this carbon compound, that for the same molecular formula, it may have the different structural formula. That is called your isomerism. The phenomena of existence of different structural formula for the same molecular formula is called isomerism, and different structures are called as the isomers. Let us consider C4H10 for simplicity. Just what do we mean by this? So one may think the carbon is there, carbon always have the 4 valency. How is that 4? So that have to be satisfied. So this carbon have satisfied the 3 valency, another with the carbon, this carbon with the hydrogen, another with the carbon. So how is this? All this structure we will see in more detail. So this is one of the structure. You count the carbon and hydrogen, you are getting it is containing 4 carbon and 10 hydrogen. So one structure is this. One may think, no, he may think this carbon, hydrogen, another carbon. There he may think this is the hydrogen, and he may think this can be the carbon, means, and this may also combine with the other carbon. Now these 2 carbon, their valency are fulfilled with the hydrogen. It is like this. Here you are observing both have the same molecular formula, but their structures are different. So they have slightly different characteristics. Okay, not entirely different. So slight difference in their physical properties. So these 2 are called as the isomers of each other. Isomers of each other. So how these isomers are drawn, those things we have to learn. And the phenomena of existence means this process is called isomerism. So isomers and isomerism, that we have to learn. Another we have learned about this functional group. Because of this functional group, the carbon is able to form large variety of the compound. So sometimes it is also called as your very friendly atom. So you may write And for particular functional group, the different compounds can be written. Say for the alcohol, it can be the methanol, ethanol, propanol. That is called as your homologous series. So write down the eighth, very friendly element, carbon as a friendly element, means it is able to form different kind of compound, friendly element. And then the ninth one is our, means why friendly? Because of their derivatives, derivative of hydrocarbon. And the ninth one is, for one particular functional group, there can be large number of the compound. Means of the same functional group, there can be different compound or different molecular formula. Say for the alcohol, there can be different kind of alcohol. Say it can be methanol, ethanol, propanol, butanol, hexanol, octanol, nonanol. Means so many kind of alcohol can be prepared. Though all are alcohol, all have the nearly the same property, but in that alcohol the quality will be different. By that way, so such group of compound form which have the same chemical characteristic, but their member group are slightly differing from each other and give slight difference in their physical properties, like their melting point differ, their boiling point differ, these things, but chemically it will be the same. That is called as your homologous group or homologous series formation. So right, this is the other unique property, homologous group or homologous series, whatever the term used, or homologous series. Means the groups having same functional group, having same functional group. Whatever the functional group here I am writing now, the same, it is this. Means if we consider for the alcohol must have this OH. So I may frame carbon, hydrogen, 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 and this another in place of hydrogen there is OH. So this is called as methanol. A student, here it is important, what about the new terms that you are getting? अभी आपको एक एक टर्म याद करते जाने, क्योंकि सारे के सारे टर्म हम आगे यूज करने वाले हैं. हाँ, so keep in mind whatever the new term and new things we are coming across, you have to keep all these terms in mind. More detail we may learn later, but these terms are quite common. Another, in place of one carbon there could be the two carbon, and their valencies are filled by the hydrogen, but it must contain this OH group. It is called as ethanol. In place of two carbon there can be the three carbon, whose all the valencies are filled with hydrogen. But OH group must be there. It is called as propanol. Okay, so all these are. So these three, all of these are, all are alcohol. But these are the different member of this alcohol. One may use this methanol. So methanol is used as the spirit, but this ethanol is used in medicine like your cough syrup as well as for the drinking purposes as the beverages. this propanol and many more. So different members have different application. So what is this homologous series? So these are the 9 important properties or topics that we have to learn. After this, these 9 topics, we will go for the chemical reaction of alcohol and carboxylic acid. So these are the 9 topics. In between this, I mean, while discussing these properties, in between, I will explain 2 important things. One is called drawing the molecular formula. What is the molecular formula? If it is given, then how to draw its structure. So molecular formula formation and their structure have to be drawn. This is another important thing that we will learn in between. So this is very important. And while writing the different molecular formula, in between I will explain the nomenclature or giving the name. So nomenclature. So these 2 things will be covered in between while we are discussing this. So while we will start with the organic compound or this hydrocarbon, saturated, unsaturated, those things we will discuss. There I will explain all these things. So whatever the organic compound, here we have written this hydrocarbon. Again, this hydrocarbon can be classified into, one is called saturated. Not only hydrocarbon, even their derivative can also be saturated or unsaturated. How to distinguish this saturated with unsaturated? What is the chemical test, like bromine water test? That is another important thing. So these are the content that we have to finish first. See, for this year, only this much is going to ask. Okay, what are their important properties and nomenclature? Only it is up to this much. The other topic like reaction of alcohol and carboxylic acid, for this year it is removed. Okay, so we will focus more over this topic. Later on we will see about these 2 topic also in brief only. So what are the important point? Only those things we will discuss about this. Then soap and detergent is also there. So let us start with the properties. Very first property of carbon called as valency. So right, valency of carbon. So what is the valency of a carbon? In parallel, we will also understand which kind of bond is formed by it, because bond formation is decided by the valency or nature of valency. So what is the valency? What is the nature of this valency? Its nature means the type of valency, whether this valency is because of loss or gain of electron or because of sharing of electron. It is called as electrovalent or covalent. So these things we have to learn. Student, let us start with the carbon. How is the carbon? How we can determine its valency and what could be its type? All these 3 things we will determine rather than just mugging up. Carbon is tetra covalent. No need to mug up. You just observe how we are getting it. A student, if we start with the carbon, we are knowing that carbon is C6 and 12. it means its atomic number is 6. It means its electronic configuration, what could be the electronic configuration? Because the electronic configuration only gives us the idea about the valency. Electronic configuration is what? Arranging the atoms in different cells. This we have learned in class 9. A student, atomic number 6, this indicate it contain 6 proton in their nucleus, as well as it contain 6 electrons which are revolving around their nucleus. So how is the structure? Here you can also calculate the number of neutron. In this case, the atomic number is 6, but atomic mass is your 12. So number of neutron is obtained by subtracting the atomic number atomic number from the atomic mass, or mass number basically. So it is like our 12 minus 6. So the number of neutron is also 6. Here I am considering the C6 and 12, means the atomic mass is 12. If you are considering say C6 with mass number 14, at that time the number of neutron will be 14 minus 6, it become 8. But this C6 and 12 is most common, or simply called as C12. So student, how is the structure of this carbon? So we have learned in class 9, atom consists of nucleus, means the entire space. If I am considering the entire space, this much space is occupied by one of the atom. Then in the center there is a very denser or heavy region, and this heavy and denser region contain two kind of subatomic particle or fundamental particle. One is called proton and another is called as neutron. So the number of proton present is 6. The number of neutron present in this nucleus or this central region is also 6. So this central region called nucleus, and electrons which are 6, they are revolving around this nucleus. So how these electrons are distributed or revolving, it is given by the electronic configuration. So let us first go for the electronic configuration for representing this atom or the structure of this atom. Student, in electronic configuration we have the different cells around the nucleus. So how many cells? That depends on the number of electron present in that atom. The innermost cell, or the cell which is quite closer to the nucleus, or the cell starting from the nucleus or near to the nucleus, is called K cell. The next one is L cell, the next one is M cell, N, like this. Okay, KLMNO, it is like this. But which cell is present, that is decided by how many electrons are there. This K cell have maximum capacity of 2 only. This L cell have maximum capacity of 8 only. This M cell have maximum capacity of 18, provided the Bohr's principle that outermost can accommodate maximum 81 only, considering those things. If M is coming as the inner one, then it may contain 18. If M is the outer one, then it can contain 81, means up to 81. Student, these are the maximum possible content. But for this carbon, we have 6 electrons. So for filling this 6 electron, first 2 electron will go here, means go in K cell. The next, how much is left? 6 minus the 2 equals to 4 is left. So the next 4 will go in M cell because this, sorry, L cell, because the L cell have maximum 8 capacity. So this 4 will go to L cell. So the electronic configuration is like this, 2 and 4. Let me also delete this. Now whether M is required, student, here we are observing all the 6 electrons. So maximum 6 electrons are there. They get exhausted or get accommodated in the beginning, or in the beginning of cell, or in the very first 2 cell. So other cell like M and N cell, these cell will not possess or not present in this atom. So this part can also be deleted. So the electronic configuration is like this: K2, L is 4. Here we are observing K is this innermost, and the second L, it is the outermost. Means for drawing the atomic structure, I need to draw the 2 circular path around this nucleus. So let me draw the 2 circular path. So let us consider this as the first circular path. Name this as K. Are we getting? This is our K cell. We are starting. So this is our K cell. It is the closed path. The other one, which will come after this, it is denoted by L cell. Therefore, the entire structure is like this. In this K cell, it will contain these 2 electrons. So these 2 electrons, let me denote it by the cross. Because of their electronic repulsion, they will try to remain apart as much as they can. Therefore, the 2 electrons need not be placed one closer to another. Rather, these 2 electrons should be drawn at diagonally opposite or with equal spacings. So it can be like this. Another one is the 4. So that 4 have to be placed in this L orbit. So place it in the L orbit. So this is the other one orbit. So place the 4. So let me place the first one here, the second one here, the third one here, and the fourth one here. So this is the outermost orbit. The electrons present in outermost orbit is called valence electron, because this outermost orbit sometime itself called as the valence orbit or valence cell. So the number of electrons present in this outermost orbit, it is called as the valence electron. So here we are getting the valence electron is how much? It is 4. So this outermost orbit, these have the tendency to accommodate 8 electrons. It always have that tendency. If 8 electrons are present in this outermost orbit, that atom will be stable. If 8 atoms are not there, 8 electrons are not there in outermost orbit, then it has the tendency to gain that 8 electron either by losing or gaining, that we have learned in our previous chapter. So that kind of valency is called electrovalent. But losing these 4 electron is not easier. Also gaining these 4, the new 4 electron is not easier because of their smaller size. If new electron is brought, large repulsion will occur. So the only possibility remains is by sharing. So those things we have to learn in more detail. So from here, the valence electron is 4. So to get 8 electron in their outermost orbit, so right, to get 8 electrons in their outermost orbit, so they already have 4 electrons. Either they need to have 4 more electrons, means the valency or the combining capacity is always for the 4 electrons. So this implies valency is what? How much more electron is required to become octet, or how much more electron is required so that the outermost orbit have 8 electrons. Here 4 is already present. How much more electron is required? That is 8 minus 4, so it is 4. Or the other way of calling this, how much electron it need to lose so that the outermost orbit have 8 electron or 2 electron. See here 2 electron means getting duet is not the stable one, that we will see. So losing is also not possible. In that case, how much electron in their outermost orbit? Still it is the 4 one. Means even if it want to lose or gain, it need to lose the 4 electron. If it need to gain, then it need to gain another 4 one. How much gain it is required to become 8? 8 minus 4, it is this 4. How much it shall lose? By the way, if possible, then also the outermost 4 electron. In this way, we are observing whether we are calculating this valency by 8 minus number of outermost or electron, or the outermost electron itself, it is always 4. Because we have learned earlier that valency in class 9th we have learned, a student, if you have doubt you may go through your previous year notes, is equals to number of outermost electrons. This outermost electron is also called as valence electron. So valency simply equals to valence electron if it is less equal 4, and it is equals to 8 minus valence electron if the valence electron is greater than 4. You can observe this. Example, if we were considering the oxygen, in class 9th we have learned the electronic configuration is 2 and 6. In this case, the valence electron is 6, but valency is obtained by 8 minus 6 by applying this second formula. So it is 2. Okay, so this is the important one. Here we are getting that the valency that we are calculating by subtracting the valence electron from the 8 is 4, or by applying the definition that this valency itself is equals to valence electron, that is also 4. So in this way we can conclude that valency of carbon is always 4. So let us write. Thus valency of carbon is 4, or better to write always 4. Therefore, when the valency is 4, the term 4 is called as tetra. Mathematically, it is called as the tetra. Therefore, carbon is tetravalent. Now the question is, if the valency is 4, whether this valency is available for losing or gaining, means positive valency or negative valency, or which kind of valency is there. For that, we have to understand the nature of valency. So let us say called covalency. So write nature of valency of carbon. How is this? A student, again, we have to consider the electronic configuration, and we have to apply the possibility of accommodating or losing electrons, whether it is possible or not. Those things we will observe or analyze, then we can say yes, whether it could be electrovalent or covalent. A student, so how is this carbon? If I consider this carbon denoted by C, its electronic configuration is like this. So for drawing this, I will just draw the outermost orbit or outermost electron. Let us just draw. Okay, no need to draw the inner orbit. For understanding this valencies and all those things, we are, and for understanding the chemical behavior, basically we are interested in their valency or their valence electron. Their innermost orbits and inner electrons are not important for the chemical behavior. So that's why we will consider only the outermost orbit. Means in outermost orbit, whatever this orbit I have drawn, it is our L cell, student. Don't think it could be, or it is the K cell in which I am going to accommodate 4 electrons. No, it is the outermost orbit. Here, now we are going to draw the 4 electrons. So let me draw the 1 electron here, another electron here, another electron here, another electron. These are the 4 electrons that we are considering. Now, a student, if you are facing difficulty, then you may first draw the complete atomic structure. Like this is the carbon, say this is the nucleus, carbon nucleus. So you may hatch it. First you draw the K cell, then you draw the L cell. You may draw like this also. Okay, it is also okay. So let us draw the inner one. Inner one just contain the 2 electrons. Cross denotes the electrons. Coming to the outer one contain the 4 electrons. These are the 4 electrons. Now the requirement is this inner one is our K cell, this is our L cell. This outermost orbit, this want to have, so to have 8 electrons. Or it could be the one possibility, or all these 4 electrons have to be lost or lose. All 4 electrons to become the duet, means the stable structure is with the inner K cell only. All 4 electrons to become a stable helium configuration. This is the only exception. This I had explained in class 9th also. How is this? Now see, water. So these are the only 2 ways to become stable. The purpose of chemical reaction or the valency or chemical bonding is to become stable. How they become stable? If they have 8 electron in their outermost orbit, then they become stable. This 8 electron is obtained either by losing or gaining. Those things we have also understand in our last chapter, by which the electrovalent bond was formed. But here we have to observe whether losing these 8 electron is possible or gaining the 8 electron is possible. Then what is the possibility? So let us consider the case 1. So to become 8 electron, let 4 new electrons is taken by a carbon atom. This I am assuming, but whether it is possible or not, to analyze that. So let 4 new electrons is taken. Then what are the possibilities? Observe it carefully. A student, let us redraw the figure. This is our nucleus. Let me draw it by plus symbol. Sorry. So for this K cell, I need only 2 electrons. So let us place the 2 electrons anywhere. So let us place these 2 electrons like this. It is okay. Now for the L cell, if we are considering the L cell, we are already having the 4 electrons which were marked in black. So student, understand this carefully. These 4 electrons are already having this. And 4 new electrons. Let me mark these 4 new electrons by this yellow color. So let us consider 4 electrons, it is being taken. Okay, see. So while putting these 4 electrons here, see, I am going to put it here, 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 and here. Say, if you are putting these 4 electrons, then what is happening? Observe it here. In this case, the nucleus is still contain how many positive charges? 4 protons. This implies 4 unit positive charge. But consider this outermost and all these things, not 4 but rather 6. Nucleus contain the 6. The 4 is balanced by the outer one. But total electrons, if you are considering, how much electrons it become? 2 was in K, 4 was there, which was the earlier, and 4 more is added. It become 10 negative. See, earlier the 4 unit, sorry, the 6 unit positive charge was balanced by the 6 unit negative charge. But now we are observing that because of the 4 extra electron taken, only the 6 positive charge inside the nucleus and 10 electrons around it, it is not able to hold these 10 electrons together. Why? Because electron will repel each other. So because of electronic repulsion, these 4 extra electrons cannot be accommodated by carbon atom. So the possibility of accommodating or gaining 4 electron is ruled out. That is important. So right. So because of this, so unbalanced. So unbalanced or more repulsion, here we can write like this, more repulsion between electrons because of the extra electron as lesser number of protons. Means here you can see just nearly 40% extra negative charge. So this cannot be balanced. But if there is only one negative charge extra, then this positive charge nucleus is able to hold it by attracting it, like it is happening in oxygen, where it can accommodate or it can hold two extra electrons, because at that time the disturbance of positive and negative charge is not that much. Also, the size of this carbon atom is very small because of only the two cells. So therefore, these four extra electrons cannot be accommodated or hold or cannot be gained by the carbon atom. So therefore, whatever this first case or assumption we are taking, that is not possible. So we have to write like this. Right? Carbon cannot gain 4 electrons because of its smaller size. There is larger repulsion between the electrons. Larger repulsion between electrons. So this way, this first possibility of taking or gaining electron is ruled out. So this implies what we were observing. If we have the chlorine atom and it is gaining one electron, it was able to form Cl minus. So it was possible because chlorine have bigger atom and only one electron is to be accommodated. So that was possible. But for the carbon to become octet configuration, it need to have 4 electrons to form C4 minus. Get it? So therefore this is not possible. So this is not possible. Ready? So carbon cannot gain 4 electrons because of its smaller size. There is larger repulsion between electrons and, continue to write in this, and C4 minus ion is not possible. Not possible. Therefore, carbon cannot have negative valency. So carbon cannot have -4 valence. Have -4 valence. So -4 valency is now ruled out. Means possibility of gaining is ruled out. Now let us consider the possibility of losing. So the case 2. Student, I had explained. Let me explain once more. See, valency means the ultimate purpose of this carbon atom is to have 8 electron in their outermost orbit or 2 electron in their outermost orbit. See, the outermost orbit is our L cell. So for 8 electron, it need to gain 4 extra electron. For outermost orbit to have 2 electrons only, it means all the 4 electron which is present in outermost L cell have to be lost, so that the structure become only C with K cell and having 2 electrons. So either this is possible or with the 8 means the 8 electron in outermost orbit, that is the possible. But which one is the possible one? So here we have first consider the 4 electron is taken by this carbon atom. if 4 electrons are taken by this carbon atom, the 4 additional or new electron, we have assumed these 4 negative electrons, it might be coming from some electropositive element, like sodium is able to give 1 electron, sodium is able to form Na plus and 1 electron, Mg. So these extra electron that we are getting here, we are taking here, is available from the sodium, magnesium, aluminium, all those things. So, but I have not taken this part, the sodium, magnesium, etc. We are just interested in understanding whether 4 electron can be accommodated by this carbon or not. If we are putting the 4 electron, so this L cell is quite a smaller. Placing these 4 extra electron, and 4 electron is already present, electronic repulsion or repulsion between electrons and electrons increases. That's why they will try to move away from each other. Who is holding this electron? It is the nucleus. Though the nucleus have only 6 positive charges, but total electron is now 10. Or for the outermost orbit, only 4 protons are there, but 8 electrons in outermost orbit, so that cannot be balanced. So therefore, C4 minus is not possible. Therefore, carbon cannot have negative valency. Now the second case, let us try to understand if it is going to lose 4 electron, then whether that is possible or not. So take the case number 2. Let carbon is losing or trying to lose electrons. See, for this, a student, let me just draw the outermost electrons, not the inner one. I am not interested in that. Consider, again observe it carefully. Let us consider this electron is being lost. We are just considering, we are removing one of the electron. For removing the electron from the atom, we need to give some energy here. This you will learn more detail in higher standard. So if you are giving the energy, then this electron is able to come out, because this electron or the electrons or the cell will get excited and that will move to the outer one, I mean away from this. So this is the energy needed. Energy needed, I am considering. So if I am giving the energy, electron will come out. Simply mean, if the carbon is there, in this you are giving the energy, it is going to give you the electron out. Okay, this is the mechanism of removing one electron. So for removing one electron, I need certain amount. Let us call that as E1. Say E1 may be your 10 joule, 20 joule. It is in the form of electron volt. You will learn in higher standard, but no need to quantify. Let us consider the energy required is E1. See, after this, how the structure become? After this, the nucleus it still contains 6 proton, but the outermost orbit have now only 3 electrons. Means now this one have, for denoting that, we are putting this in a bracket and writing this with a positive charge, because nucleus have 6 protons, but the electron 2 in K cell and 3 in L cell, so 5 electrons. So there is a mismatch, means 6 positive but 5 negative, So here we are getting the net 1 positive is there. So that this 1 positive is denoted by this plus symbol, putting it in a bracket or a square bracket. Okay, student? It is like this. Say by, so this state to this state, reaching from the normal neutral state to the ionized state, it needs the amount of energy, say E1. Get it? Now, for becoming the carbon 2 plus, what we need? We need to remove this further. So one of the electron, maybe this or maybe this or maybe this. Any one of the three have to be removed. Getting? For that, we have to understand how much energy is now required. A student, see, under the first condition, when the atom is neutral, in this case, the 6 proton is balancing the 6 electron. Now, when the C plus, this is the structure of our C plus only, carbon with 1 unit positive charge, it have 6 proton and 5 electron. It means these 6 proton will hold the 5 electrons tightly. Means it is able to pull it even closer to the nucleus. So this implies, means after this, electrons, this we will learn in next chapter also, called periodic table, where I will explain after forming the cation and anion how the size changes. It is asked in your NTSE. So there I will explain more. But here you can also understand simply, because of the higher nuclear charge and lesser number of electrons, means the positive charge is more, so electron get attracted. So the size of this ion, means C plus, will decrease. So electrons come closer to nucleus. Therefore, see why? Because of more attraction. So attraction increases. Now, up to this much, now again, suppose we want to remove one more electron from this C plus. Our target is to reach from C normal carbon to carbon 4 plus. Our purpose is to reach this one. I had explained just one step how it can first reach carbon to carbon plus. It will losing one electron. Then it is for your understanding. It may be possible to lose all the 4, but the process or the energy required will remain the same. What I am explaining one by one. Then let us consider it is going to form 2 unit positive charge, then it is going to form 3 unit positive charge, then it is going to form 4 unit positive charge. Okay, so this is the step that I am going to explain. Say up to this much we have done. The energy requirement was E1. Here we have marked this as E1. Now from C plus to C double plus, how much energy is required? That we will try to understand. Now see, a student, we have this C plus, means it is like this one. From this C plus, again we want to remove, this is the, sorry, so this is the plus, so we have to put the plus sign over it. Now I want to remove this electron. See, again I want to remove this. What I need? Again I need some energy. A student, I have to put some energy or give some energy. Can anyone tell me the energy required value E2? I am assuming this as the value required, the value of energy required for removing one of the electron from the C plus as E2, so that this electron is going to come out. So whether this E2 will be equal to E1, same as E1, or E2 will be greater or lesser than E1, or E2, take this as 2, is your greater than E1. Yeah, student, you have to answer it. Now for removing one more electron, the energy required is increasing or decreasing, that we want to know. Yes, tell me.
Sir, E2 will be greater than E1.
Yes, sir.
Okay, everyone, a student, is agree with this? Yes. Neeraj, why E2 will be
Yes.
greater than E1?
Sir, as you told, the electron will come closer to nucleus, so
Very good. A student, here I have written electron came closer to the nucleus, means now more force of attraction. Now you are knowing that if your friend is holding the biscuit, I mean, very strongly, you cannot snatch it, but he is just holding it by the open hand, you can quickly snatch it. It is like that. Means now these three electrons are held by the nucleus very tightly because it have already lost one of the electron. So more energy is required to remove the additional, to remove the second electron from the C plus. So right here, this is the correct one. These two are the wrong one. Ready? So right. So the energy required increases, and this increase is not only the single time but many times. Say the 10 kilojoule is required for the first time, for the second time it may be the 40 kilojoule. So after 40 kilojoule, if we want to remove the third electron, again 180 kilojoule. So that kind of exponential variation is there. Therefore, removing all the 4 electrons is not possible. It's so simple. So energy required increases as one of the electron is lost. This is called ionization potential. Student, there are means this itself is a big topic called electron affinity, ionization potential. All these things you will learn in class 11th and 12th. Those terms I do not want to use it here. So though in your book it is there, they have also not used. They have also used only the statement whatever I have written. The force of repulsion increases, it cannot hold by layman language or by applying the simple terminology. Is this not possible? The neither gaining of 4 electron is possible, not losing of 4 electron is possible. So it is simply written in that manner. So we also have to keep that much only in our mind. So this way, here we have observed the energy required for losing the electron increases because of a smaller size of the carbon atom. So what we can conclude, the same for the third one. For the third electrons, if I am considering, or electron I am considering, E3, if you are considering, may be possible, it will be much greater than E2, greater than E1. Means though you want to remove this electron to make it stable, but it is gaining energy. So gaining energy means the system become unstable. You are already knowing, if any object is placed on the ground, it have lesser energy, but if it is placed at certain height, it have more energy. So it is like this. Though we were tending to remove this electron to make it stable, or to make it for the stable electronic configuration, but we are giving more and more energy, means it is become more unstable. Therefore this loss of the 4 electron is not possible. So we will write that statement directly. The loss of 4 electrons by carbon atom to form C4 plus is not possible because of why? Same, a smaller size and increase in force of attraction. Because of a smaller size and increase in force of attraction. Increase in force of attraction. Between whom this attraction force we are considering, students? The nucleus and the electrons that I have explained. Okay? Attraction between nucleus and outer electrons and outer electrons. So that's why we can simply write C to become C4 plus 4 electrons means losing 4 electron is not possible. Not possible. Why not possible? This I had explained above, considering the energy and everything. But you have to keep in mind at least this statement. It is very important, student, because it is asked in your MCQs, and always ask why electropositive or electronegative is not possible. So these two conclusions what I have written, these two are very important, student. So from above analysis what we have observed, that we are going to write. So thus carbon can neither form C4 plus or C4 minus. So neither form C4 minus nor C4 plus. So that is forming this positive ion, negative ion is called what? Electrovalency. Okay, that is electrovalency. Electrovalency, or forming compound by losing or gaining electron, or forming bond by losing or gaining electron, or forming the bond by forming the ions is not possible. Therefore electrovalency is not possible for carbon. Then the question arises, if this carbon which contain 4 electrons in their outermost orbit, to become stable it needs the 8 electrons, neither it can gain nor it can lose, then how this carbon can complete their octet configuration? So how to complete octet configuration? Octet configuration means outermost orbit must have 8 electrons. Do not think that it will accommodate entirely the 8. So how, what are the possibilities that we are going to see? Configuration. See, a student, now we have to think a bit differently, where neither transfer nor, neither loss nor gain is permitted. In that case, what is possibility? A student, for writing that, let us consider a practical example. Consider Neeraj and this Vivek. Both of you have gone to a fair or any place or to any market, and both of you feel that or observe that there is a toy whose cost is 100 rupees, and both of you are liking, and you have gone to the market together. But each of you have 50 rupees, but both of you want to purchase. Is it possible to purchase? If, then how? Say, the Neeraj will ask, Vivek, you just give me the 50 rupees. Then Vivek will say, no, no, no. Even I also need this. You please give me. So none of you will agree to totally donate or to give the 50 rupees. But there is another mechanism or another way or another agreement that both of you will come together. Since both of you are liking, then you will agree, okay, so we need to purchase this by sharing 50 rupees each. Yes, I have 50, I am giving this 50, you also give this 50, let us purchase it in share. For that, you will say, in morning I will play, in evening you give it to me, I will play. Again, next morning you give it to me, I will play, in evening again I will give it to you, you will play. It means the toy will remain under the ownership of whom? Whether Neeraj or Vivek or both. So under the control of both of you. So that is the other possibility. So this possibility or the same kind of agreement or possibility is also there for the atoms to form their molecule. So such a kind of bond formation is called covalent bond. Okay, so that mode. Let us see what are the possibilities. See, I am considering, say, oxygen. I have the carbon and oxygen. I'm just considering these two atoms. So before writing why it is covalent, I'm just taking carbon and oxygen. A student, write down their electronic configuration. We are interested in their valence electron. So just put the 4 cross here. Okay, writing the symbol for the 4 cross. This we have done earlier. For oxygen, there are total how much? Oxygen is 8, configuration is 2 and 6. The student, be careful. So these 6 electrons we have to place it. Okay, student. See, now if this carbon come closer to oxygen, then what is the possibility by which both of them will have 8 electrons in their outermost orbit? Observe carefully, student. Again, see, if oxygen is there, oxygen have the tendency to gain 2 electrons. Oxygen do not have any problem in getting 2 electrons. But can this carbon give their 2 electrons to this? But the carbon cannot lose their 2 electrons. It means carbon shall not combine with oxygen, if you are thinking that way. But practically it is found that carbon is combining with oxygen. Then what is the other mechanism or other way? That way we are going to understand. Though oxygen is ready to accept the 2 electron, but carbon will not give. So that's why this 2 electron is not totally transferred to the oxygen. So what are the other way? The other way is that this carbon will say, okay, friend oxygen, you need 2 electron. So what I can do, observe it carefully, student. If you have any doubt, then please ask in between. Once you understand, the covalent bond is over. So see, I am considering this carbon. Carbon have 4 electrons like this. I am considering the oxygen. Oxygen have 6 electrons. Let me draw like this. It is like this. It is possible that this carbon will say, no, no, I will not give you totally, or I will not transfer my electron to you, because I am also in need of the electrons. So let us come closer to each other. So what will happen? Earlier the structure was like this one. Say carbon was totally circular and oxygen was also totally circular atom. So what will happen? This carbon will extend their boundary and oxygen will also extend their boundary in the region of carbon. Now the boundary get modified. So these electrons, what was for the carbon, it will come under the influence or control of oxygen. Whatever the electron of oxygen, this will also come under the influence of carbon. It means one of the electron will just link each other. The similar fashion, the other electron will also get linked with each other. So such a linking, for such a linking, I have to take care how the structure becomes. So let me just draw like this, oxygen like this. Now, for the oxygen atom, you count the number of electrons. So 6 electrons, 6 are the black electron, which was of the oxygen itself. But the 2 more electron is shared by the carbon. So the 2 new electron or the blue electron is now also under the control, not total control, but partial control of the oxygen. So oxygen have now total 8 electrons. So this way, this oxygen becomes stable. It is able to get attached with the carbon. But whether the carbon is here stable? No, still it is not stable. Then how? Then what will happen? Then this carbon will search for the other oxygen atom. If the other oxygen fellow come closer to this carbon, then this new oxygen fellow will also share its 2 more electron with the same carbon with which the earlier the other oxygen have shared. So let me consider this new oxygen that will also extend their boundary so that 2 electron of the carbon gets shared with it. Now these 2 will get bonded. Keep in mind, 1 electron just get shared with each other or get bonded with each other. So we'll always think equal number. So it is like this. Now coming to this oxygen. For this oxygen on left hand side, how many electron? 1, 2, 3, 4, 5, 6. 6 which was with the oxygen, but 2 more electron, blue electron of the carbon. It is now also under the control of oxygen. So this oxygen also have now 8 electrons. See, oxygen have the configuration 2 and 6, but after sharing, the configuration have gone to 2 and 8, but not by gaining, but by sharing. Okay, student, this was the mechanism. Now let us come to the carbon. Now let us count for the carbon. How many electrons are there for the carbon? Yes, count for the carbon. For this carbon here, we are observing the 4 was their own, means the carbon itself, 1, 2, 3, 4. But while sharing, the region or area of influence or the orbit have get modified. So 2 electrons, the black electrons of the oxygen on the right hand side, that is also under the influence or under the control of carbon. So 4 plus 2 become 8. Additionally, 2 more electron, the orange electron of the oxygen on left hand side, these 2 electrons are also under the control. Now this carbon have total 4 plus 2 means total 8 electrons. So these 8, I am talking for the outermost orbit. Forget the L cell. We are talking for the, forget the K cell. We are talking for L cell. So this way what we are getting, that this 1 carbon have combined with 2 oxygen so that this carbon have 8 electrons by sharing, Both of these oxygen also have 8 electrons, but these 8 electrons are obtained by, so obtained or achieved by sharing. Do not mean 8 electrons are shared. Carbon have shared their 4 electrons, 2 with one oxygen, 2 with other oxygen. While one of the oxygen have shared only 2 electrons, because sharing is always in equal amount. The other oxygen have also shared their 2 electrons with the carbon. This way, one carbon get associated with the 2 oxygen. So this is obtained, means the 8 electrons is obtained by sharing of 4 electrons of carbon with the 2 oxygen atoms, each sharing how much? 2 electrons. Means each oxygen is sharing 2 electrons. 2 electrons. Are we getting? It is very important, student. That's why I am explaining each and everything. So this way, this method of achieving the stable configuration is called covalence. And what will be the formula? Here, one carbon by the rule of constant proportion, one carbon is combining with 2 oxygen. So writing 2 oxygen is written in the bottom. So CO2 is the formula. So CO2 is which kind of compound? So a covalent compound. Covalent compound. May such a compound formed by sharing of electron is called covalent. So this is the only possible ways for the carbon to achieve their octet configuration. Are we getting? So write that point. Thus, the only way to achieve octet configuration for carbon is by sharing of electrons. So this is the only way. And the bond formed by sharing of electron is called covalent bond. And the bond means associating, the force of attraction which can hold 2 or more atoms together. And the bond formed is called covalent bond. Ready? So thus carbon is covalent, or carbon have covalency, better to use that. Carbon have covalency, cannot have electrovalency. Electrovalency means losing or gaining, then forming the bond by forming the ion, that we have learned in last chapter. Cannot be electrovalent. Okay, students. So combining the two things, what we can write? Thus, carbon is tetra. Means how much covalency? This covalency is 4 in number. 4 in number. Why? The valency that we have calculated earlier, it need 4 electrons, or it always need 4 electrons. That is obtained by sharing of electrons. Carbon is tetra covalent atom or element. Better word is element. Or atoms, you can also write. Atom you can. So this is very important. I had explained everything, then we have reached to this conclusion. Just before stopping the class, let us make one compound of this carbon. Say carbon or compound of carbon and hydrogen, if we want to, of a carbon with hydrogens, means only one carbon atom is there and hydrogen as much as you need you can do. Then what could be the compound? Students, see, hydrogen we have learned only one valency. Hydrogen have the electronic configuration, K cell itself have only one. So it have the tendency to gain 2 electrons, means gain 1 more electrons, so that become H minus. If it is gaining, means if it is gaining 1 electron, or if it is sharing, then there is no charge. Keep in mind, if there is sharing of electrons, then there is no charge development. So that's why it is called as covalent. So student, how this is possible? See, here we have this carbon. Carbon have 4 electrons. So mark it 4. But if we consider the hydrogen, hydrogen have only 1 electrons. So hydrogen can share maximum only 1 electrons. So put the electron of hydrogen like this. Hydrogen itself have the tendency to have 2 electrons only in their outermost orbit. That is the tendency, whether it is by gaining. If it is formed by gaining, then there will be the negative charge. If it is formed by sharing, then this negative charge will not be there. It's so simple. It is like this one. So this have the hydrogen have the tendency to convert into helium configuration. So it is happening here. Now this hydrogen will absorb, means the 1 electron of carbon gets shared with one of the hydrogen. The second electron of carbon gets shared with the second hydrogen. Sharing is always equal in number. Third one, and the fourth with the fourth one. But what about the carbon? Carbon orbit will get modified. So for carbon, the jurisdiction or the region of carbon or influence of carbon is up to this much. Get it? So it is like this. So to simplify the way of writing this structure, we are just writing this carbon, then we are just putting the bond here. Means 1 pair like here, like here, like here. Okay. So this is the simplest way of writing. Now, how was this? So by this approach, how the carbon dioxide can be represented or can be represented? If the earlier we had drawn the carbon dioxide CO2, the carbon have shared the 2 electrons with the oxygen and the other 2 electrons with the other oxygen. Therefore, the bond form are like this, the two lines or two bond with one of the carbon. So when two bonds means it is called as the double bond. If only one is there, it is called as the single bond. So each of this carbon and oxygen have here single bond. In CH4, it is your single bond. So double bond is formed. How the structure is represented? The other four, sorry, draw it by the dotted one. So the oxygen is like this one. Draw the structure of oxygen, the other oxygen, and for the carbon, this is much easiest. So how to draw in simplest form? Carbon is forming two bonds because sharing of two electron from the carbon to the oxygen means two pair of electron is shared with one of the oxygen. The same way the two pair with the other of the oxygen. So this is the simplest structure. So in simplest structure, it is drawn like this. Carbon is drawn at the center and two oxygen are drawn after this. So this is the structure. So drawing this, it is called as a structural formula. Are we getting? So write covalent bond leads to octet configuration without forming ions or charge. Do not form any ions. So these are also called as non-ionic bond. This I had explained in last chapter also. So this was all about. So here we have concluded that what is covalent bond, why the carbon is covalent, why it cannot be the electrovalent. All these things I have explained. So let us stop the class here. A student, if you have any doubt, then please ask. Otherwise, note down the homework. Yes, student, any doubt?
Let me just scroll down.
Yes, note it. This is the final structure and final point that you have to keep in mind. So what is difference between covalent and electrovalent? Covalent bond is formed by sharing. There is no charge separation. It is non-ionic. It will not conduct electricity. Other properties, whatever we have learned earlier, everything is known to you. It will not conduct electricity. There is no charge separation. So here the electrons are shared. You may write one more line. So here electrons are shared in equal number. And no complete transfer and no complete transfer from one atom to another. Means the shared electron is under the control of both. That is shared electrons or electrons under control of both. Means whatever the combining atoms, say for this shared carbon and oxygen, the 2 electrons, getting, with one kind of oxygen and other 2 electrons with the other kind of oxygen, with both atoms. So such a compound is called as covalent compound. Valent compound is non-ionic, so do not conduct electricity. Conduct electricity. Whatever I have explained earlier, electrovalent and covalent, the differences you can analyze and more you can. So student, I think we cannot do anything in this chemistry. So मैथ्स को जो हमने मैथमेटिकल ऑपरेटर्स आपको बताए हैं एनटीएससी के लिए, आप वो फिनिश करिए. लास्ट डे मैथ्स में हमने जो चैप्टर नंबर 6 दैट द ट्रायंगल्स दैट वी हैव डन, प्लीज फिनिश दिस. इसमें यदि किसी के कोई होमवर्क है या कोई डाउट्स हैं, प्लीज फिनिश दोस थिंग. एंड इफ पॉसिबल इसके जो लास्ट ईयर के पेपर्स हैं दैट आई विल आल्सो पोस्ट. सो आवर नेक्स्ट क्लास टुमारो. Tomorrow again at the same time. Yes, student, any student have any doubt, then please ask. Any doubt, student? So next day we will continue with this. We will start with forming the different kind of bonds of carbon with other atoms, that we will start. And the other important property like catenation, allotropism, those things we will finish tomorrow. No doubt? I hope so.
No doubt, sir.
None of the students have any doubt?
No doubt, sir.
Okay, good. It means we can stop the class here.